right, guys, so on this next set of problems here, I'm looking at problem number 4 and problem 11. So let's look at problem number 4 first. It says a quadratic function is given below, and it gives you the function. Using a graph of the function, determine which statement is not a true description of this quadratic function. So there's a lot of things going on here. I'm actually going to make this just a little bit bigger. All right. So I need a statement that is not a true description, okay? It also tells me that I have to look at a graph of the function. So I may want to actually plug that in and see what's going on there because it doesn't actually give me the graph, okay? Let's go ahead and pull up that calculator and start plugging that in. So I've got y equals, and I'm going to plug in x squared minus 5x minus 24. And I'm going to look at the table. Okay. I can hardly see the bottom of this or the top, so I may want to zoom out once or twice. So I'm going to zoom out once. There it is. Okay. So if I look at my parabola here, I notice that I have the lowest point or the lowest vertex down here at the bottom. Okay, and let's see. If I look at my answer choices here, I'm looking for the statement that is not true. And if I look at them, it says the graph is symmetric. There are zeros, vertex, y-intercept. I'm basically looking at a bunch of characteristics for this quadratic. And honestly, while the graph, I can see everything, I can't actually see what the specific numbers are. So I'm probably going to want to look at my table. So I'm going to hit second graph. Okay. And if I notice here, J says the y-intercept is 0, negative 24. Well, as soon as I hit second graph, when x is 0, y is negative 24. That is the y-intercept. So that is actually a true statement. So I'm going to put like a T right here for true. I'm looking for the not true, so it cannot be J. Okay. Let's see. Zeros of the function. Okay. One of them is at 8, 0, and the other one is at negative 3, 0. And if I look at G, that is also a true statement. So that's probably also not going to be my answer choice. So I'm probably going to put that right there. The next one has to do with either the graph being symmetric when x is 2.5 and the vertex is at 2.5, negative 25. So if I look at my calculator here, I'll make this just a little bit bigger. So my vertex, when I looked at the graph, is the lowest point in the graph. So like my graph is going down, it's decreasing, decreasing, decreasing. It has a point here, and then it starts to increase again. So that's kind of the pattern I want to look for in my table. So if I notice I'm at 0, I'm going from negative 10 to negative 18 to negative 24. It looks like I'm decreasing because I'm getting lower into the negatives. And then I notice here it's at negative 30 and then negative 30 again. And if I notice here, it looks like it's starting to increase again. So I want to go back, and I notice that these two numbers are the same for the y values. So my vertex probably hit somewhere in between. So I need to figure out, well, what number did it hit in between? So I'm going to go to second window. I'll start my table at negative 3. I'll keep that there. And I want to put my table, my TBL at 0.5 because I want it to find in between those two numbers there. And when I do that, I go back to my table and notice now all the x's have 0.5s. So I can kind of see those in-betweens. And I wanted to look between the 2 and the 3. And if I see here at 2.5, my y value is negative 30.25. So if I look here, H says the vertex is at 2.5 comma negative 25. And if I notice here, the y is actually supposed to be negative 30.25. So that is actually not true. So H would be my not true statement. All right. And then let's see. I look at 11. Which quadratic function in vertex form can be represented by the graph that has a vertex at 3 and -7 and passes through that point 1 and -10? All right, so I have some characteristics that are similar to problem number 4. I have 4 answer choices with equations, and one of those answer choices has to have a vertex of 3, -7, and runs through that point 1 and -10. So when I go through here, I'm basically going to plug these answer choices into my calculator to see which of them has that vertex and goes through that point. So for example, kind of like this one on number 4, we plugged in the equation to see which of those characteristics matched. Okay, so I'm going to go and reset my calculator, and I'm going to type in that equation. Let's just start with A. So y equals, and then your fraction is alpha, y equals, the first option's already highlighted. I'm going to put 3 over 4, and then I had a parenthesis there, and it was x plus 3 inside, so x plus 3, close it. And then it's to the power of 2. I think that was plus 7. Yeah, that's plus 7. Okay. So I typed that in. Look at my graph. There's my parabola. Okay. And then I'm looking at second table to see if at 1 is my y value -10. Well, at 1, my y value is 19, so that definitely couldn't have been it. Even though I haven't checked the vertex, I know for a fact that can't be it because the y value is different than what I needed. So then I would just continue to go through all the answer choices to see which of those matches the 2 criteria, the 2 characteristics that I'm looking for. So for problems 4 and 11, what did you need to look for in order to find your correct answer choice? So I needed to plug the equations into the y equals. Then I had to find characteristics of each equation to match what I needed. And that's exactly the steps that I took. I plugged the equations into my y equals, and on number 4, I had 4 different characteristics to look at. Number 11, luckily, I only had 2 characteristics to look at. Had to go through that point and had to have that vertex. Okay. Right, on to the next one.